moving right along. We're going to bring on the folks from tinyVision.ai. These folks are so cool. Welcome, 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 everyone. We've got 3 of the folks who work with tinyVision here today. How are y'all doing?
Hello.
Hello.
Thank you for having us.
Thank you for joining. Oh.
You can keep the video on.
I'm sure Venkat will be back in just a moment. We're always learning new things when it comes to using technology. There he is. He's back.
I'm sorry, I pressed the wrong button. The button looks exactly like the share screen button.
It's true. We like to make it extra complicated around here and have some hidden traps. You're not the first person who's done it today. On this program, the share screen is the little screen with the plus sign in it.
Yes. Okay. Yeah. Thanks for having us. So just to give you a little bit of background about the company, we've been around since 2018, and feel free to read through this. But we've a bunch of people from all over. We're trying to get on every continent, I think. Joshua is in France. Let's see, is Vishal here? Not sure if he's.
Yeah.
Yes. Hey, Vishal is from Bangalore. I'm in San Diego. So distributed set of people. Really, everybody who's interested in working on stuff in a pretty hands-on team. Joshua, would you like to give a little bit of introduction about yourself and Vishal, and then we can go on with the rest of it?
Sure. I'm a former system administrator who got curious about the lower level and trying to go lower and lower levels. That brought me to firmware, which is what I do today. And I try to interact with FPGA as well a little bit through tinyVision project, which is start to be a little bit more on the hardware side. Firmware is also a lot about looking at hardware all day long to try to get it to work. So it's relevant to have open hardware in that regard, because firmware makes is a lot easier when you have access to the information from below.
Vishal, a little bit about yourself.
Sure. Hello, everyone. My name is Vishal, and I look after sales and marketing at tinyVision. And I'm very happy to be joining this call.
And little background about myself. So Vishal and I were classmates back in engineering, and we got together and started working on this since last year, I think. And really, at the end of the day, we want to build stuff, right? So we've been participating in the open source hardware ecosystem for a while. These are some of the not necessarily open source hardware certified, but they are open source. The UPDuino is something that we've been working on. It's it's a little FTDI with an ICE40 lattice semiconductor FPGA. And this was started in 2019 or 2018, and it's been going on since then. It's done in KiCad, and the whole design is open source. But we just have not taken the step to get it OSHW certified. There's quite a reasonable community around this board. The really nice thing is the tools are all open source, even for the FPGA programming. And it just downloads very quickly. You don't have to deal with all these licenses and to just start coding and learning about hardware. The Pico ICE and Pico 2 ICE are OSHW certified. So the new one is the Pico 2, which is based on the RP2350. These two boards are used at many universities for learning. A lot of makers seem to be interested in them. Really, these are, think of them as a Swiss Army knife, right? Because we bring all the pins out, and it's in reasonably low cost. And there was the other one, which was the first project that we worked on when I started the company in 2018, which is the Vision FPGA SOM. That is not done in, that's done in Altium, but the files are available, so you're welcome to go look at it. This was crowdfunded through Crowd Supply. And we're working on other open source hardware as well, which is follow on to the Pico Ice, which is the Pico 2 NX, which is based on a larger FPGA, much more capable FPGA. Also, syzygy is an open standard. We're trying to build an open source board for that, which can support multiple cameras. So this is kind of the open source side of the company. There is also the closed source side, which is really where we work on contracts and stuff. I don't want to talk too much about our products, but I wanted to show you take you through a tour of the place that we build all this, and also to the goal of this talk is really not to sell stuff. It is really to my hope is that you will take some of the information here and be able to start something on your own, and to really talk about the things that we've learned over time on how to build stuff and how to sell it, and what are all the different tools that we use. So I want to go through some of that and field questions along the way. Okay, so let's start off with, oh, I forgot about this completely, so sorry. Hardware is not complete without software. And so been working on Zephyr. Joshua really started this off. And Joshua, would you like to say a few words about Zephyr and the libmpics?
Yes, sure. There's a lot of open hardware and sometimes just commercial boards without the schematics, but almost always the schematics, and sometimes it's OSHA certification that makes a very great start. And then as soon as you get some complicated hardware in your hand, I think most of the project here also says all the software is on GitHub. That's the second step after you have the hardware is the hardware supported, because otherwise you won't be able to do something out of it. So both of these projects are basically hardware support. Zephyr is RTOS to support the chips, and libmpics is very specialized for camera image processing, but for tuning the colors. For chips that don't have hardware to process the image, this is a replacement library that does the same thing that the hardware will do, but in software. So it's also a little bit about hardware support in a way, how to enable the chips with software at a different level, at the level of the platform for Zephyr, or at the level of the data. So how to make use of the data you receive for libmpics. I think Venkat, will you have a more general presentation of that, or do you want me to present more of it?
No, feel free to talk a little bit about the motivations for Zephyr, and as well as the libmpics that you created.
Okay, so in the context of tinyVision, bringing Zephyr is really enabling the developer to use the hardware. Once you have the hardware, you will hope to not have to dive into something too specific to this hardware, but instead find your software ecosystem that enables the hardware, but not discover a new software for every hardware. So that brings the need for some kind of universal API that adapts to every hardware. So if you are doing open hardware, you might be interested in looking up, it can be Zephyr for RTOS, it can be all the ecosystem for all the kind of hardware. So looking up what kind of software can I plug my hardware to, so that I can make use of it, integrate it into something bigger, so that you do not have to redo all the software stack yourself. So that's what we have been doing also with tinyVision projects, is for USB connectivity of camera, and this was connecting the hardware FPGA, right drivers, and then everything else use the existing API of the Zephyr RTOS. And on the side of libmpics, it's a little bit different. The goal is that if you want to receive camera signal images, the camera signal might be already prepared and look good, like a video call like right now. The colors looks okay, the contrast looks fine, there is no, the image is not too much noise. But in some cases, you will get raw sensor data, like people working with telescopes. They always talk about raw Bayer image data. I want to get the raw image from my camera. That is something the camera is expected to be processing to turn it into good-looking images. If you look at the raw images, they will look, oh, that's all green, that's weird contrast. So you have to process this data. And often we think of it as part of the hardware because it's always part of the camera. You forget about it. And it's true. If you get a commercial camera, there will be some hardware doing that as well as some software. And a first step to open up the camera stack for microcontrollers, for the small camera, is to provide this as software, the little box that takes the raw images in, that produce the good-looking corrected images out that you will recognize as normal-looking images. And that was one attempt to avoid repeating the same work for every closed or client-specific project, was to do an open-source library that brings this missing block of every camera hardware, so that it can be used for every project, as well as someone else who wants to play with camera raw images that come from the sensor. That's a duality working with a platform, getting a platform working by bringing hardware and then connecting to open software ecosystem. And the other, where there is some specialized field domain, is to try to do the extra work to provide some libraries that can deal with the data produced by the hardware. So that integration of the platform at the hardware level, and integration of the data produced by the hardware specialized to one use case, for instance, sensor data in this case. That's the idea.
Yeah, thank you, Joshua. I think one of the interesting things is some of you might have heard of the Brilliant Labs smart glasses. So the LibMPix is part of that now, of the latest smart glasses. Anybody else, Joshua, that you can disclose, or not really? Who's using the LibMPix?
Well, yes, Seed Studio is using that. They're doing their open source hardware because they publish the schematics. I'm not sure they have OSHA certification for all their hardware, but they do have some of their devices that start to be using that. They've been providing a huge amount of software for this. It's very valuable, along with other people who contribute to it, but do not always publish their name. And anybody who needs that is going to use it without saying it. It's also perfectly fine.
Okay, thank you. We wanted to show you the factory where we rent space at. So just a little bit of background. This is not our factory, right? But I have the great fortune of being able to rent space in this and being at the machines. And this is something that my younger self would have loved to have access to. Now I do have access, and wanted to show you guys some of the machines there and how we build our stuff. So take a look at the video. Please put down your questions. Happy to answer them after that. Here's the SMP factory. The parts on the wall. So let's start at the beginning of all this. We have parts that come in inventory. They go through a paste printer. And once this prints the paste, you can see the print heads down there. That prints on the paste like a dot matrix printer. Goes into an SMP machine here, where parts are on feeders, and then they get fed in, and then a bunch of them get put on the board. Once they come off the line, they go into this really cool vapor phase reflow oven. do look it up. This is a really interesting piece of technology. And once it comes out of there, we have 3 SMP lines in this place. So there's an identical one here. There's one in the back that's going to be set up. And there's one here. And once they come out, they go into the optical inspection. And once it's inspected, we also have access to a little X-ray machine that is down here. So we can X-ray things to look at them. And then all this place is for storage, rework. Oh, and way back, that tower is full of parts. There's a little robot in there that pulls out reels when we want them. Everything is barcoded. So carriers here have little barcodes on them. Every carrier has a barcode on it. Right? And those barcodes go into our scan, and there are barcodes for everything. This factory runs on barcodes. So that was a little bit of background of the factory. I find the optical inspection machines also absolutely fascinating. So I made a short video about that. This is going through our the Pico 2 eyes, which made it nice and purple. So the background of this is that when you're in production, you need to be able to tell when parts are either tombstoned or just wrong parts or whatever it is, right? So this thing uses image processing to find parts, and this is what you find in a commercial factory, so that you can build things at scale. So with that background, this is the teaching part, I guess, or the learning. This is what I've learned over the past 7-8 years, is when you start building open source or any product, you need to be able to sell it to people. These are the storefronts we are on. And by the way, this didn't happen overnight, right? It's taken a long time for us to get there. So we set up our own store on Shopify, and Tindy was available. Then Electrons came up. Electro have a partnership with them, and most recently with Vishal's help, we've been able to get into DigiKey. That's not yet fully there, but we're getting there. In terms of payment gateways, we signed up for both PayPal and Stripe, and the reason is simply because Shopify forces you into one, and then you're already using. And Stripe was used by I think Electrons. So those are the 2 payment gateways. They differ a little bit in terms of their fees, but otherwise it's not too bad. For shipping and labels, because these are shipped from the US, we use this service called ShipStation. There's also Shopify, which has its own shipping service. And the most useful thing there is the roll-up printer. So printing labels rather than writing out addresses. I mean, this is like, it's really worth getting one of these printers. It costs about $70-80 or something, but totally worth getting a printer once you start building more than 10 per month or so. In terms of board assembly, of course, JLC PCB, many of you will be aware of it, as well as a few other manufacturers. I didn't list them, but Electro also helps build some of our boards. And of course, the SMP line, where we rent some space. The huge advantage of being able to rent space at an SMP line is that you really learn how boards are put together. So if you want to make your boards manufacturable, then that is the place. You'll see the pain that operators go through. It's like you need to minimize the number of line items. So making a board manufacturable, the best way is to go find a place that you can see what these operators are going through. Right? Testing is super important because once these boards are built, you can have optical inspection, but at the same time, you really need to test them. We do a very simple connectivity check. Right? We're not trying to test for functionality. That's a very different thing. So when you do the design, there's design verification and test. And then what we're doing here is production testing. What we settled on is a very simple daisy chain. If you have like a Pico ICE, for example, you just connect all the pins together in a huge daisy chain and drive a square wave through it. And at the end, hook it up to an LED. So once you push it down on a pogo fixture, and the fixture has the part of the daisy chain, and the rest of the daisy chain goes through the part itself, you can detect shorted pins as well as open pins. Those are the only two things you're checking for. Is the part soldered down properly or not? And with this, we've been able to get very fast testing. We use MicroPython running on these devices, and it's really easy to do that. Happy to take questions on this. And yeah, we have a Discord. Feel free to join. And all our work is on GitHub as well. Let me try to see our window so that I can see if there's any questions or comments.
We had a few comments from Chipperdoodle, who said, I used to work on a Micronic PNP, familiar site. So looks like your workspace is something some folks have spent some time with too, as well as we had one of those AOI machines too. So lots of fun. It's always fun to see what tools spread across the community and how folks are utilizing them in industry.
Yeah, thank you guys so much for like sharing the factory space and like really sharing like the breadth of your process. I feel like that was really super helpful. And yeah, thank you so much for taking the time to share a bit about your work with us.
Yeah, and I hope, I'm not sure what the process is. Do we send our slides over so that people can?
Yeah, if you have links,
like
everything, yeah, you can send them over. We'll make sure they go out over our socials and people can connect with you and reach out if they want to hear a bit more.
Okay. Yeah, I'm hoping that maybe even one person picks up some of the information here and sets up their own little thing.
I think it's definitely possible. Well, thank you guys so much. And yeah, we will be hearing from you soon.
Thank you so much.
Thanks, y'all. See you next time.
Thank you.